Hi everyone, this is Jake Fry, and today I'm going to talk about motion in higher dimensions than 1D. So, how do we describe motion in higher dimensions? So all we need to do is to separate each of the vectors into components and treat each component separately. So for example, if gravity only acts along the vertical component of velocity, then the horizontal component of velocity will be unaffected by acceleration, so we can separate it completely out. And by separating vectors by components, we can individually address each direction when doing things like calculating derivatives or integrals, or when we set up our kinematic equations. And so in the future, we will discuss what it would mean if you have like a force that acts on both and mixes the x component or the y component together. That would require things like higher dimensional calculus. But for now, we can just separate the components and set up our problem such that the force will only act on a single one of the components. And then we can treat each component as a separate 1D problem. Alright, so in kinematics, we can do exactly that, separating out the x component and the y component. And again, with kinematics, we have constant acceleration, so we have equations just like these two, or I guess four, where all that's different between the equations is that the subscripts, or the x and the y, indicate if you're going along the horizontal direction or the vertical direction. Alright, so now one very well-known special case, which is extremely similar to the freefall case that I talked about before, is the case of projectile motion. So, in projectile motion, you have acceleration only along one of the two axes of motion. So typically you have it along the y direction, the vertical direction. And so if you were to ignore what's happening in the horizontal direction, the object would just go, exactly like free fall, dropping it, and it would accelerate due to constant acceleration due to gravity. And so by adding that extra component in the x direction, you'll see that the object will create an arc, a projectile-like motion, or it will take the form of a parabola. And so the special case requires that you have an acceleration of 0 in the x direction and a non-zero acceleration in the y direction. Alright, and so in that scenario, we can generate new kinematic equations that address having acceleration just along the y direction. And in these kinematic equations, we've replaced the symbol a for acceleration along the y with g, which is a common way to say the acceleration due to gravity. Cool. And now a brief thing to mention about the range and height equations. So you might see these in many of the problems that you are going to be doing in projectile motion. And so you might think that these equations here don't give you all the information you need in order to solve for the range of a projectile or the maximum height that it reaches. So this isn't actually the case. You can use these equations more generally than the range or the height equation. And so, I would strongly recommend to ignore the range and the height equations because they are not general equations. So typically what happens is that you'll have a problem that you'll be asked for the range of a projectile. So say, a ball is thrown at a given angle, and how far does it go if the initial velocity overall is 10 miles per hour. And so if you're throwing your ball at the same height as where you're checking to see where it lands, then you could use the range equation or the height equation. But that's a very rare case in problems. Usually, you'll be throwing the ball and it'll be the height of a person and see where it lands on the ground. And so the height mismatch will cause the range equation to be invalid. But height mismatch definitely does not cause these equations to be invalid, because you can still put in a initial height and, yeah, in both initial height in the y direction and an initial position in the x. So yeah, so just, I would strongly recommend ignoring range and height equations. All right, so now we've been using rectilinear Cartesian coordinates, and so do you have to do that with these two-dimensional motion equations? So the answer is no, and we'll see that in our next lecture, actually series of lectures, we'll talk about how a two-dimensional system works if you use something like polar coordinates instead of these rectilinear Cartesian coordinates. And so we'll have many things like circular motion that we'll describe in the next video. So hopefully this video was helpful, and in very soon videos I will make quite a lot of examples going through each of these kinematic equations.